Good morning or afternoon, whenever you are going to be watching this. So we're going to get into today's lesson, which is talking about the rates from different graphs in straight lines. Again, I'm going to go to the calendar. I'm referring to the calendar because this is where all your information is going to be for the foreseeable future. Every lesson plan will be here, and I will press this link, which sends me to the OneNote page. This will be filled with notes once you watch this. But from now, we'll just get started. The questions are at the top there, here. So if you want to have a read of this and maybe start doing the questions while I'm explaining, go for it. But otherwise, we'll just get straight into it. So we talked about gradient last lesson, and we defined gradient. We defined the gradient as the rate of change of y. Rate of change of y as x changes. So as x changes, how much does y change? That is how we define the gradient. Well, if we want to find the rate of change, if we want to try and find the rate of change of a line, we just have to look at how steep the line is. And we also know that how steep the line is actually just the gradient of that line. And I'm going to link these two together because rate of change of a line and the gradient of the line, really, they're the exact same thing when we're referring to straight lines and the rate of which they're changing. So a rate compares two quantities. So if we have two quantities and we're trying to compare them, that is how we say a rate. For example, meters per second is a rate. Kilometers per hour is another rate. Speed is an often example of these rates. We could also have pay rates for those of you who have jobs. So let's say $10 per hour are two quantities being compared to each other. Many rates show quantity change over time. It's probably the most common one, because time is always changing. It's a good thing to measure to. Changes over time. So let's say we've got a distance time graph, and I'm not going to put my little thing in it. I'm just going to draw a set of axes. So let's say we've got that, and then let's go flat. There. Okay, so this will be my distance in kilometers. If you are asked to draw any of these, it's really important that you put the units on your axes because that is going to help you try and find your rate. And so let's say this here is going to get me to 2, and then this is 50, and that's 100. And I'm going to draw a line at 100, 2, and then I'm going to connect that to my start. I obviously haven't traveled any time at the start at 0, so I'm going to connect this point 0 to that line there. Now if I want to try and find the gradient of this line, let's remember that the gradient is always going to be equal to rise over run. But we also just said that the gradient and the rate of change is the exact same thing. So this is also equal to the rate. So the gradient is equal to the rate, which is equal to rise over run. So this here, that's going to be my rise. So I'm going up 100 kilometers, and I'm going to divide that by my run. And my run in this situation is my 2 hours. That is my run. So 100 kilometers over 2 hours, well, that's going to leave me with 50 kilometers per hour. That is my rate, but it is also my gradient of the line. The gradient is going to be 50 and the rate is per hour. Any rate in example is the change in quantity 1, divided by the change in quantity 2. For the example that I'm going to use it here, that's the change in quantity over the change in time. If the rate is per time, then it will always be over the change in time. So the change in quantity could be like liters, could be kilograms, could be meters, and then time, seconds, hours, etc. So we know all these other ones. Then probably the most important part of today is this part here. The gradient gives you the rate. So the gradient is a rate of change on itself. It's the rate of change of y compared to x. And so if we need the rate of change of just any line, we find the gradient. The gradient gives us the rate. The gradient gives us the rate. A few common rates we know are speeds, okay, so kilometers per hour, meters per second. These types of rates are really common, and we're probably going to deal with speed rates a lot in this chapter because that's going to be the questions that they ask. To calculate a rate from a linear graph, we need to find the gradient and include the units measured. Find the gradient and include units. And include units. Okay, so I'm going to scroll back up and notice here, okay, this is where I'm going to be talking about. Oh my god. Other way. So I have found the gradient of my line by dividing my rise, which is my 100 kilometers, over my run, which is 2 hours. 100 divided by 2 is 50, but I've included my units here, okay? That is because to find a rate, we want the actual units. Rates will always involve units, so it's important to remember that we're talking about that here. Include your units. So for example, it would be y units divided by my x units. Because it's rise over run, your rise is always your change in y, the run is always the change in x. Okay, and let's just do a quick example so we're making sure we know what we're talking about. So from the graph below, and now just bear with me while I draw a set of axes in here. So we want to have that. And then we want to have this. Okay, this is going to be my time in hours. And my distance in kilometers. Sorry, the unit should be in brackets, not the title. So now, without figuring out any other measurements, we can pick up straight away that my rate is going to be kilometers per hour, because up here, my rate is my y units over my x units. My y units is kilometers, my x units are hours, and so my rate is going to be kilometers per hour. So we can tell it's probably a speed question. Okay, so let's say I have 1, 2, 3, 4, 5 hours, and let's say we've got 50 100, and 150. And then let's put in my points. Now, I know this example. You won't know this until the end. But we're going to have a certain distance time graph. And it'll look something like this once it is all drawn. So maybe when I'm done finishing this, pause the video so you can copy it down. And then we can start working. So make sure you've got that completely copied down, and then I'm going to start working through the questions. So the first thing I want to know is, what is the speed? What is the speed during the first hour? What is the speed during the first hour? Well, we know that that just means I need to try and find the rate. But if I'm trying to find the rate, I'm also just trying to find the gradient of the line. So the rate is equal to the gradient, which equals rise over run. Well, my rise in this situation is going to be this here, which is 50. My run is 1. Okay, so therefore, that's going to give me an answer of 50 kilometers over 1 hour, which equals 50 kilometers per hour. So that is my speed for the first hour. Now I want to figure out what is the speed of the middle segment. So you see that this distance time graph is split into 3 sections. We have our first section here, we have our second section here, and our third one there. Okay, so we are after this middle section. Okay, and now that is a flat line there. From my middle section, I'm a flat line. And so since it's a flat line, it means I'm not going anywhere. It means that my distance is not increasing at all. We can also relate this back to how we remembered the other lesson, how a flat line always has a gradient of 2. If it has a gradient of 2, it has a gradient of 0. If it has a gradient of 0, it has a rate of 0. And so we know that it is just equal to 0 kilometers per hour. So that is all we should need to know for this topic. Again, I'm going to scroll up to the top. Questions are up here, and if you guys have any other questions, feel free to email me if you want to talk about it.